When we first started out on this topic, I was trying to explain the number e, but the way I did it was that I rushed through everything. I tried to squeeze everything into one video, and there's no way you can explain the number e all in one video. And then we went and did some work on logarithms, and I wanted you to get a feel of using logs and how to manipulate logs. So now we're going to start all over again and try and understand the number e right from the start. Okay, but this time we're going to take it step by step, so that we can fully understand the number e. So the number e is the number e occurs when you try to differentiate this thing here. So suppose you have a graph y equals a to the power of x. Well, a to the power of x, let's see, a to the power of 0 equals 1. So at this point here, when x equals 0 here, it always crosses 1. So even if you have y equals 3 to the power of x, it will still cross over at 1. Even if you have x to the power of, let's say, 7x, it will still cross over at 1, because 7 to the power of 0 is 1, 3 to the power of 0 is 1. So if you have a graph of y equals a to the power of x here, it will always cross over 1, no matter what a is. Okay, and then if you have a look at a to the power of 1, that will always be a. So when x equals 1, right here, when x equals 1, if you move all the way up, this point here will always be at a. Okay, so the number e occurs when you try to differentiate y equals a to the power of x. Now, to differentiate, as normal, we would set up 2 points, a and b. We would set up 2 points, a and b, and then we would try and get the point b to move closer and closer and closer towards a. So we are taking the limit as h. H is this distance here. So h moves about left and right, well, h moves about. You can slide h back and forth like this, and then eventually we want to get h to get closer and closer and closer and closer towards a. Okay, so we're decreasing h. We're taking the limit as h tends to 0. So to differentiate this, we will set up 2 points, a and b. So we would get this height, and this height is given by this, taking away this. Okay, and then we would and then divided by the across here, which is h here, and then take the limit as h tends to 0. Okay, and then this bit here will then become this. Okay, because a to the remember from indices, x to the power of a plus b, that's the same as x a and then times x to the power of b. So basically this thing here becomes this. Okay, and then notice that you've got, at the moment, you've got this block taking away this block here. A to the power of x is in common here, and it's in common here. So you can factor out a to the power of x. Okay, so factor out a to the power of x. That will then give you this. And then now, if you look at this here, if you look at the diagram here, h is the thing that's moving about. So you're sliding h back and forth, and then slowly decreasing h. So h is a thing that's moving about. This thing here is really a constant. It stays the same. Well, here you're taking a limit, meaning that you're making h smaller and smaller. You're moving h about. So this thing here is independent of h. So you can actually take it out of the limit. Okay. So looking at this here. Hang on. So remember, h is a thing that's moving about. And then this block here is independent of h. As you move h about, this thing here stays the same. It's independent of h. So you can actually factor out this. Well, you can actually take it out here. So now just concentrate on finding out the limit of this. Remember, from our section on limits, there's a law that allows us to take this out. So you just have to accept this bit. Okay, so take it out, and then switch these two blocks around. So that this block here, well, yeah, switch them two around. So whenever you differentiate, so dy by dx is given by this complicated thing that we don't understand yet, times with itself. So what that means is when given y equals a to the power of x, if you differentiate it, it will give you a complicated thing that we don't understand times by itself. So times by itself. Okay. If you want to differentiate this, it will give you something times by itself. Okay. So what that means is this: if you're given y equals 7 to the power of x, if you differentiate this, it will be some magical thing. It would be some magical thing times by itself. But remember, this magical thing, if you look at it, this magical thing, hang on. So if you're given this a here, this magical thing depends on this a here. So hang on. So when you differentiate this, it will be some magical thing times by itself. But the magical thing, let's call it m. But then it does depend on this 7. Because if you look at this here, the magical thing here does depend on a here. So in our case, it's 7 here. So that means this magical thing here depends on the number a. It depends on the number a. So when you differentiate this, it will be some magical thing times by itself. But then this magical thing here does depend on the number 7. So it does, whatever this number is, it's going to depend on this number here, whatever this number here is. So if you try to differentiate y equals 3 to the power of x, it will be some magical thing times by itself here. But then this magical thing here does depend on this number 3 here. Okay, but in short, the important part is this: when you differentiate y equals a to the power of x, it will be this thing here times by itself. So now we're going to try and investigate this thing here. We're going to try and understand it a bit more, okay, in the next video.